video tutorials here looking at what I'm calling triangle formulae. These formulas are to do with trigonometry and triangles. So we already know about SOHCAHTOA and the idea of calculating sides and angles using sine, cos and tan functions. But these have always got to be right-angled triangles. So we're going to have a look at some formulas that are going to help us work with triangles that are not right-angled. So we've got three formulas that we're going to learn about. We've got the sine rule and the cosine rule. There's actually two versions of the cosine rule, as we'll see, and a formula to help work out the area of a triangle. All of these have got trig functions in it, as we'll see. So we're going to start with the sine rule. So if we have a look at the sine rule, we need a triangle, of course. This is a scalene triangle. We've got capital letters at each vertex representing the angle, and what I'm going to do is I'm going to bring in the formula so you can actually see it. Here we go. So you'll notice that there are three equivalent fractions here. For those of you who know about the formula that we use for calculating fractions of a circle, the angles, arc length and sector area, it works in the same way as that. So you'll notice that on the top, in the numerator, there are lowercase a, b and c, and on the bottom, capital A, B and C. Capital A, B and C relate to the actual number sizes of the angles. So if A happened to be, say, 110 degrees, then A, capital A, would be 110. What about these lowercase letters? And we haven't actually found out where they go. So we label our sides in a triangle, like we did with right-angled trig when you would put hypotenuse, opposite and adjacent. What we do this time around is we label the sides this way. The side that is opposite angle A, capital A, the side opposite is lowercase a. The side opposite capital B is lowercase b, and the side opposite capital C is lowercase c. So these are actually the lengths of the sides, and the capital A's are to do with the angles. Okay. So how do we actually use it in practice? Well, let's have a look at an example. Example 1, calculate the length of the line BC. BC is here. I put an X here just to represent the side that we don't know. We've got some information, and you'll notice that we've got A, B and C as our vertices, so we're going to write out the sine rule in terms of A, B and C. So we've got here A over sine A. Just have a wee bit of, okay, sine A is equal to B over sine B is equal to C over sine capital C. So what we're going to do, you don't have to use this method, but it's a good starting point. Circle the thing that you don't know in the formula. We don't know the length of BC. Well, hang on, we don't know what to put A, B and C are. So we have to label our sides. Capital A, opposite that is side lowercase a. Opposite angle B is side small b. Opposite angle C is side small c. So that tells us that we don't know, or we want to know, small a. So we put a circle around that to say that's what we want. What information do we have? We've got information about side small c, which is 15 centimeters, so we can tick that. We also know angle capital A, so we can tick that. And we know angle capital C, so we can tick that. And what we're looking for is a circle and a tick in one fraction, two ticks in another, and it doesn't really matter what we know about the third fraction, because we're always going to eliminate one fraction and be left with an pair of equivalent fractions. So A over sine A equals C over sine C. At this stage, I'll substitute in what we know. I've called the unknown side x, so I'm going to write in x here instead of small a over sine of A. Now this time we can replace capital A with 65 degrees is equal to, small c is 15, and the sine of capital C is 47 degrees. Okay, so there we go. We haven't actually done any calculating yet, but we have created a pair of fractions that are equal to each other. So at this point, we could do a little bit of cross multiplying. We don't actually need to multiply both of them out, in the sense that we don't need to multiply x times sine of 47 and 15 times sine 65. Really, if you think about it, we just want x on its own. So we take this sine 65, which is dividing on the one side. On the other side, it will multiply. So we can keep the x here is equal to 15 times sine 65, because we're bringing this up from the bottom of the fraction. Sorry, my pen's a little bit funny here, so just bear with me. All over the sine of 47 degrees. Okay, and at that point only, do we reach for a calculator. So it says here x is equal to, and we take my calculator, 15 multiplied by the sine of 65. Just watch to close any brackets on your calculator, divided by the sine of 47, and you should get 18.588. 18.588. You can round it to whatever would be helpful. I'll round it to one decimal place. The other thing is the question actually said calculate the length of BC, so I'm actually going to finish it off by answering in the form that was asked of me. The length of BC is 18.6 centimeters to 1 decimal place. Okay, and that kind of makes sense because the unknown side here is opposite an angle of 65 degrees, which is a bigger angle than 47, which opens out to a 15 centimeter line. So we would expect BC to be slightly longer than AB, which is what we've found. Okay, let's try another one just to get started. Now that we've worked out, that's basically what the sine rule is for calculating sides. So here's another triangle that doesn't use A, B, and C. So that's slightly different. Calculate the length of EG. Let's find EG here. So that's the side that we're trying to find the length of. Let's label our sides first of all. Capital E, opposite that is small e. And then opposite F is small f, opposite G, small g. And we write out the sine rule in terms of E, F, and G this time. So I'm going to write it out in alphabetical order. You don't have to, but we've got E over sine E equals F over sine F equals G over sine G. Okay, so what do? We circle the thing that we want to find out. We want to calculate EG. That's small f, so I'm just going to leave it as f. I'm not going to put in an x or an a or anything. Just going to call that f. I know 3.2 meters is on side E, so I can tick that. I know angle F, so I can tick that, and I know angle E. Great. So we've got a circle and a tick on one fraction, and we've got two ticks on another. We can scrap fraction G, and we can then substitute in based on what we've got here. So we've got 3.2 for E over the sine of 136 degrees is equal to F, well, we're still calling FF at the moment, and sine FF is 28, so sine capital F 28 degrees. Okay, this time the unknown's on the right hand side. It's not a big deal. We can see that again this dividing by sine 28 should come up to the left hand side and become multiplied by 28, or do multiply both sides by sine 20, whatever your algebra is. So I'm going to flip it all around. So I've got f on the left-hand side is equal to 3.2 multiplied by the sine of 28 all over the sine of 136 degrees. There we go. I can work that out on my calculator. 3.2 multiplied by the sine of 28 divided by the sine of 136. Make sure your calculator is in decimals, not degrees mode, D or DG, EG, rather than radians or anything. So make sure your calculator's in the right mode. I'm getting 2.162. So we'll round it again to one decimal place. Also, the question asked for the length of EG, not for the length of small f. So I'm going to swap in the correct term. EG is 2.2, and it's meters this time, to 1 decimal place. Okay, look, there's one other example we're going to use just now, and then I'll let you practice this. So here we've got a third example. What's different about this, or what do I need to bear in mind about P, Q, and R? That's okay. I'm going to label my sides, small p, small q, and small r. It says calculate the length of PR. PR. So that's this one here. We could circle it in a diagram as well. So we're looking for Q. If I write out P over sine P equals Q over the sine of Q equals R over the sine of R, something interesting is about to happen here, because we want Q. We know capital P angle, and we know capital R angle, and we know R here, lowercase r, so we tick that. Right, but we've got a wee problem because we've got a circle here, but we don't have a tick under the circle. So this is a problem here, that we've got not the right information. We need to know Q, otherwise we can't use this fraction here. So if you have a look at the triangle, if you know two angles in a triangle, remember that the sum of all the angles in a triangle is 180 degrees, right? Sum of all the angles is 180. That means if you know two of them, we can quickly work out the third one. So 93 and 33 is 126 degrees. And what adds up, what's the supplement of 126? 54 degrees. So you can quickly work that out. So just because you don't have the information given to you doesn't mean you can't work some things out. So now we've got Q as well, and even though we've got part of that third fraction there, we're going to just dismiss fraction P, and we're going to finish off, close off the problem using Q and R. So we don't know what small q is, that's what we're trying to find. We'll keep it as that, over the sine of capital Q is 54 degrees, equals small r is 65 over the sine of R, which is 33 degrees. What we're doing with our cross multiplying, we've got Q, we've got dividing by sine 54, that's going to multiply up here. We can rewrite it as Q equals 65 multiplied by sine of 54 degrees over the sine of 33 degrees. Take your calculator, work it out. 65 times the sine of 54 divided by the sine of 33, we get 96.55. Just going to double check that. 65 times the sine of 54 divided by the sine of 33, 96.55. And what's that? Again, we're asked to calculate the length of PR, so I'm going to swap that in. PR is equal to 96.6 centimetres. PR, would that be right? Well, it seems to be 33 degrees opens out to 65 centimetres, so it's fair enough that 54 degrees would open out to a side longer than that. Okay, so that's how we calculate the lengths of sides using the sine rule. Go away and practice that, and at the moment, the reference, if you have the online textbooks, it's book 2, page 69, and it's question 1, just question 1, okay? And use the answers to check your progress in all of that. Okay, I hope that's been helpful. The next video is going to be about using the same rule to calculate angles. So let's you can join in on that once you're done with this.